has a subtitle, what kind of conductor material is preferred, aluminum or copper? Well, again, it's a great pleasure, and I will start now with the first slide. I show you now a table of contents indicating which subjects will be dealt with in this webinar. We start with an introduction. Then I give you an approach, how we did that work in the past and presenting now the results. We're talking about different options for installing cable. I tell you about international practice. I will say a few words about the multi-purpose tunnel, a tunnel that's being used by not only electricity utility but other owners of infrastructure as well. Then I give a comparison between copper and aluminum in ducts, and followed by a comparison of copper and aluminium in tunnels. Followed by evaluation, what did it learn us, conclusions, and I give at the end some references, literature that I have used to come to this presentation. The introduction. Well, you can install a cable in a few different ways. The most popular and the most well-known is direct buried. The cable is installed in a trench with soil and everything happens in that surroundings. You can also install a cable in ducts, and the ducts is a combination of pipes in concrete, not necessarily, but sometimes in concrete, and you have to pull a cable in such a pipe in a duct. The third option is a cable installed in a tunnel. The tunnel, so you clamp the cable somewhere and the cable is part of that tunnel, easily accessible for maintenance, and it's completely independent from all kinds of other activities in the neighborhood of that tunnel. There's a fourth option not mentioned, but I just tell it you that you can also install a cable on a bridge. It's not happening frequently, but you can do that. Well, the question you can raise is, what are the pros and cons of ducts and tunnels as installation methods as such? And the second question, what is the impact of these installation methods on the selection of conductor material, copper versus aluminum? Which approach did we take? Well, first we started to investigate international situation. Who is using ducts, who is using tunnels, what are their experiences, what are pros and cons. We made that list, second bullet, the list of pros and cons. And then the third bullet, what is the impact on the selection of conductor material? And finally, what are the future aspects? What is present happening and what may we expect in the future? In this survey, I give you some information about direct buried ducts. I also mentioned pipe. It is almost the same, but it's not exactly the same, but comparable. And then the tunnel. And I use economics, the inconvenience to public, the current rating, maintenance, protection. And I give numbers. Major advantage is 4, advantage is 3, disadvantage 2, and a major disadvantage 1. Well, when you look to direct buried, you see the economics, we give it a 3. So it's not the most expensive. The other ones are more expensive, 2 for ducts, pipe 2, and for a tunnel, that is very expensive. We give a 1. So that is certainly a disadvantage of a tunnel, that it's costly. Then the inconvenience, Well, there is certainly inconvenience when you have direct buried. If you open the trench, other people cannot use the street anymore. So we give it a 2. A duct, we think that's 3. And the pipe, 3, and the tunnel as well. The current rating, that is for a direct buried system a 3. For the duct and the pipe, it's not that good, so we make it a 2. But for the tunnel, we can go higher for rating because we can easily transport the air by ventilation and increase the rating. So we give it a 4. The maintenance, that is for direct buried really a major disadvantage. If you wanted to do something, you must open the trench, which is in a city a very difficult and unpleasant process. For the duct, it is a 2. It's better. The pipe the same. And for the tunnel, it's the most convenient way to do maintenance in the tunnel. So we give it a 3. Then the protection. That is for direct buried, not that good. So we still call it a disadvantage. For the duct, it's better. But for the tunnel, it's the best. Because only when somebody makes a mistake, you can get a damage. But when everybody obeys the rules, then nothing can happen. So that's in a brief overview of the different installation methods. And you can see the tunnel is scoring relatively high. It has higher numbers than the others, 2 times 4, 2 times 3. But only the economics, that is poor, that's 1. And that's completely correct. The tunnel is a very nice solution, but it is expensive. The international practice about ducts, well, in urban areas it's used. A large number of crossing services, a restricted use of mechanical diggers, civil activities and cable installation are separated, an excellent mechanical protection, and finally, one of the safest types of installation regarding safety in case of short circuit. There are situations in case of short circuit that the cable comes out of the trench. It is not happening daily, but there are examples that when there's a high short circuit current, you can get such tremendous mechanical forces and the cable can come out. This will not happen when the cable is installed in a duct, as we all understand. So to summarize, the international practice for duct is you apply it in the city because then when it's installed, the street need not to be opened again, and it gives a good protection against mechanical damage and against short circuits. What is the international practice of tunnels? Just briefly explained, of course. Well, if space in the underground is scarce and no ducts are possible, then a tunnel is an option. Tunnels are used for a long time for traffic, waterways, for power cables, and for other services, telecom, sewage, gas pipes, city heating, etc. Tunnels are designed to enable easy maintenance, repair, and replacement of services in that tunnel. A tunnel can be equipped with ventilation, and that's not only to give fresh air for maintenance persons, but also to increase the rating, as we can show later. Nowadays, multi-purpose tunnels, and these tunnels are hosting electricity, oil, gas, water, etc., are becoming more and more common because of cost sharing. But I said already, a tunnel is very expensive. If you only have it exploited by one utility, then the costs are heavy. When the costs are shared by others, it becomes more attractive. I personally believe that the multi-purpose tunnel has a great future. Well, we come back and we go in a little more detail about the multi-purpose tunnel in this slide. A multi-purpose tunnel is to be compared with carpooling. we all know that if you have a car and you share the cost by others, it becomes cheaper per person, but your freedom goes down as well, because you have to leave at the same time, you come back at the same time, you follow the same route. And so that is the price you have to pay for lower cost, that you lost freedom. So the pros are clear: sharing investment costs, organizing and maintaining underground infrastructure in a structured way. Not everybody has his own tunnel, but you order it in one system, and of course it has major advantages. What are the cons? Well, the management structure is complicated. You have several owners, and they all have their requirements, and so you need a contract where you should promise to respect all these things, and it can be complicated. And finally, there can be a mutual impact of the different infrastructures. When a system gives some heat, then the tunnel goes up in temperature and it has to cool down for the others, particularly for cable. So these are the main points. For costs, it's good. For ordering all kinds of infrastructures, it's good, but it's not as good for the management structure and the organization schemes, and for the possible mutual impact. What are essential services in a multi-purpose tunnel? Well, lighting, ventilation, drainage of seepage, emergency procedures, communications, fire and smoke detection. I may say that fire is a very important issue. Many tunnels have been suffering from fire, and it's very dangerous, and it may destruct completely the tunnel for years. There are examples that after the fire it took several years before the tunnel could be used again. The fire extinguishing measures. How do you stop a fire? That's important. You cannot completely rely on the fire brigade, because when the risk is too high, the fire brigade is not going down. So you have to consider their own method of extinguishing and not rely on the help of the fire brigade. A pipe leak detection. A pipe can leak. What do we do then? Protection of personnel. Firm-in barriers or other animals. How can you keep them out? EMC control. The temperature control is important. Emergency power supplies and management of the multi-purpose tunnel. And I may add one aspect which is very important nowadays. That is, what do you do against terrorism? Because a tunnel is vulnerable. A terrorist can enter a tunnel and destroy an enormous part of the infrastructure. So what to do, how to protect, all these things are relevant when talking about a multi-purpose tunnel. Talking about the cooling. The cooling inside the duct in a tunnel is convection and radiation. And I may say it's also a small part still the conduction. Because the heat transfer from the wall to the surrounded soil is conduction, but you could also say the air is standing here at the bottom, is not moving, and that gives a heat conduction, a heat transport via the conduction, but here it is radiation and convection. When the cable has small dimensions compared to the diameter, there is more convection, and when the cable has almost the same diameter, then you get more conduction, and convection is much more efficient than conduction. Here you see it in the situation in a tunnel. We have here cables, and the heat is going up and comes down here, and we call this convection. But radiation and a little contribution from conduction is happening as well. Here you see the current rating in a duct. When the external diameter goes up, you see there is an increase in rating. So depending on the diameter of the duct relative to the diameter of the cable, there is an increase because you get more contribution from heat convection than conduction. This is a comparison of a number of cables with different conductor cross-section: 3000 aluminum, 2000 copper, 2000 aluminum, 1200 copper, 1000 aluminum, 630. When you calculate the rating, they are almost the same. So 3000 aluminum is equivalent with, let's say, 2000 copper. There is a difference in diameter. As we all can see, 2000 is much less than 3000. That means in a duct, you get an improving of the heat transfer, but also when there is more space, the cooling is easier. So that makes the copper conductor cable more attractive. We come to that later in more detail, because of the radial size. Copper cable has a smaller diameter with the same current rating. This is a physical model of the heat transfer in a tunnel. And I tell you, it's a complicated picture. I try not to go into all details, but to explain briefly what the principles are of this current rating model. Well, this is the cable, and I must say, in this particular calculation model, we had a duct in a tunnel. So there was a tunnel, then a duct with cables, and then you get the tunnel itself, the tunnel wall. So you had the cables, they were in a duct. In the tunnel, you had the duct wall, then you go to the tunnel wall, and the ambient. The heat had to go from the cable where it's developed, and you have three contributions in the conductor, in the dielectric, and in the sheath, and that heat has to pass all these positions before it comes outside the tunnel, and then it can, via the soil, go to the ambient. We have resistances, and they represent a certain type of heat transfer. This one is heat radiation. This one is heat convection, and also a little heat conduction. It's complicated, I said. This is a resistance only, but here you have the same radiation, convection, and conduction. This is only conduction. What do we see here? Here, heat in the duct can also be removed by flowing air, by a ventilator. And when you remove the heat, actually, it need not to go radially outside. So this makes the picture even more complicated, the heat transfer to the air in the duct. Because in this particular example, it was assumed that the duct in the tunnel had a ventilation separated from the other one, and you could blow away the air in that duct. And that was particularly done to improve the efficiency, but I think it was not realized for other reasons. Well, I hope you understand the picture. It is complicated, it's a complicated process, but when you have such a model, you can easily then put in all the data and calculate. Maybe I have to tell also that these resistances are not fixed, but depending on the temperature. So they can vary because of the temperature. That makes it even more complicated. This picture gives a simple relation between speed of ventilation and the temperature. And you see for a certain speed, 1 meter per second, you go to 5 or 6, you can go down with the temperature. So the cooling can happen efficiently by just using the actual flow of the air via a ventilator. A higher ventilation speed will increase the cooling capacity, and the higher ventilation speed will increase the current rating of the cable. And that is a major advantage, that quite easily the rating can be increased by increasing the speed. Of course, there is a limit. You cannot allow in a tunnel a speed of 6 or, well, even 4 meters per second is a high speed. And there's another limitation. When there is a fire, the high ventilation speed can increase the fire, so it must be switched off immediately. Now I come to pros and cons of ducts. If the cable will be installed in a duct, there are the following advantages. The cable has a mechanical protection against third-party damage, that's clear. After the installation of the ducts, it's not needed to open the streets for maintenance or repair of the cables. And it's a proven technology. In some countries, ducts are very popular. In the United States, for instance, in the large cities. But in my country, the Netherlands, we don't use it. Then what is the disadvantage of installing the cable in ducts? Well, high installation costs. After installing diameter restriction for new cables, and there is a reduced current rating compared to direct buried. But the restriction for diameter is important. If you have a certain diameter in a duct system, then it is not advisable to pull in a cable which has a larger diameter because you may get serious problems. What are the pros and cons of tunnels? If the cable will be installed in a tunnel, there are the following advantages. The cables are well protected against mechanical damage, like in the duct. After the installation of a tunnel, it's not needed to open the streets anymore, similar for the ducts. The higher current rating compared with direct buried, in particular when forced air cooling is applied. That's new. It is a proven technology. In many countries, these tunnels exist. The underground infrastructure, in case of multi-purpose tunnel, is well ordered, and it's easy to perform maintenance to the cable. What can we say about disadvantages of installing cables in a tunnel? Well, for the duct, I go back to the other slide to show you. For the duct, I said high installation cost. I have to say for the tunnel, very high investment cost. However, there is a light at the end of the tunnel. However, this could be reduced by using multi-purpose tunnels, where the costs are shared by different parties. The complicated organizational structure and mutual risk between cable and other infrastructures in the multi-purpose tunnel is a disadvantage. But, of course, with good rules and good structure, good organization schemes, you can manage this very well. And now we come to the subject of copper versus aluminum in ducts. When we're talking about ducts, and now looking, is there anything to say about preference for copper or aluminum? Well, the power cables are pulled through the ducts from manhole to manhole. The manhole is a place where you prepare the joints. The distance between the manholes is about, 800, maybe 1,000 meters. The distance between the manholes is depending on the maximum pulling cable length. The longer cable you can pull, the longer can be the distance. The maximum cable pulling length depends on the tensile strength and the specific weight. Copper has a higher tensile strength than aluminum, but also a higher specific weight, as we all know. And finally, calculations I cannot give you the details now, but I give you just a result. Final calculations showed a lower maximum pulling length than for aluminum. And that has to do with the fact that the aluminum has a lower specific weight than copper. Copper has a lower coefficient of expansion than aluminum, causing less thermal mechanical problems at the joints, where the cable has an overlength, and that can result in thrusts at the joint place in the manhole. And finally, copper has a lower specific electrical resistivity, as we all know, than aluminum, and therefore requiring smaller copper conductor cross-section than for aluminum for the same current rating, resulting in two things: less space that can be easily pulling and more flexibility in bends, because the bending force is proportional to the second power of the cross-section. What do we get when we compare copper and aluminum in tunnels? Well, in tunnels, copper conductor cables have the advantage to be used for the longer lengths. That has to do with you can store on a drum more copper cable for the same rating than aluminum because of the reduced radial size and the higher tensile strength. Because of the smaller radial size, copper conductor cables have a smaller size and are more flexible and have a smaller cooling surface. So that plays a role in the tunnel. Because of the lower coefficient of expansion of copper, the sag of cables between the clamps due to thermal effects is less. Consequently, copper conductor cables should require less space than the aluminum alternative. And finally, the power cables are secured with clamps to hold the power cable in place in case of short circuit current and to allow controlled expansion during normal operation. But the weight of copper cable is twice the weight of aluminum, therefore requiring special attention. What are the future trends? We expect that more tunnels and ducts will be applied for installing cables, and that all has to do with the fact that utilities are forced by local government to put things together in well-structured systems. You get no permission to put it in the ground where you like to have it. No, you must go to a certain place, and then it is logical that a structure should have a duct or a tunnel. The future tunnel, and I'm quite certain of that, the future tunnel will be multi-purpose tunnel and will probably therefore become more attractive than the ducts. And that is a matter of cost. When you have enough shared participation, then the cost can become attractive and maybe even more attractive than ducts. But that is a matter of the future development. And finally, the legislative pressure will increase to use the tunnel or ducts. Yes, what I said in the beginning, the local governments supported by the public opinion will say, we don't want the street open every time again, and we wanted to have it all hidden for us under the ground, and then a tunnel is a very attractive, the duct as well, a very attractive solution for doing that. When we look to the evaluation of main pros and cons, for ducts, copper conductor has following pros and cons. The pros are the limited radial size and the lower coefficient of expansion. These are interesting properties for ducts where copper is better than aluminum. What are the cons? Yeah, that it has a higher specific weight. Copper is heavier than aluminum. And for tunnels, copper conductor has the following pros and cons. The pros are lower coefficient of expansion, the longer installed length, and the high mechanical strength. I think the longer installed length is a relevant issue. May I explain? People don't, let's say utilities, hesitate to install joints in a tunnel because the risk of failure is, normally speaking, higher for a joint than for a cable. So they wanted to have these joints outside the tunnel, but then you must install a longer length, and that can, with a copper cable, easier than this aluminum. What is the negative point of copper in a tunnel? The higher specific weight. So the clamps are heavier, and you have to be careful that they stay in place in case of a short circuit. I come now to conclusions. Copper has a strong position in existing ducts because of the radial size. You may understand that if a duct is developed for copper cable in the past, because then the only option was copper, then it's very difficult to pull in an aluminum cable for the same rating, because then there's probably not enough space to do that. So in an existing duct, this copper, it will remain copper. For new ducts and for tunnels, there are pros and cons. Although copper has good possibilities due to low coefficient of expansion, and particularly in case of tunnel, the application due to a longer allowable cable lengths, avoiding therefore the installation of joints. And finally, the legislative pressure will increase to use tunnel or ducts for installing cables in the future. These are my conclusions of this webinar. And here I have a list of references. Quite often these are Seagray technical brochures, 194 construction, laying and installation techniques, the technical brochure 403 cable systems in multipurpose or shared structures, then the Seagray B1 109 cable installation technology for tunnels and ducts in Japan. That's a paper. That's another paper, Seagray B1 electrical power transmission with cable systems in the underground of London. And an old paper, Seagray 21 from 1998, new 400 kV long distance cable systems. The question number 5 from Tatsuo Kurata, Japan, that was in the Seagray session, an extra high voltage cable installation technology for effective utilization of existing infrastructure. And finally, a sheet cable paper from 2007 by Frank de Wild and myself. Well, this brings me to the end of this webinar. Thank you very much for your attention, and I will be very pleased to answer your questions. Thank you very much.